The video you are watching now is gradually increasing in brightness. Brightness is a subjective term. We perceive it. You could pause this video, examine it frame by frame, and tell me if one frame appears brighter than the previous frame to you. The human eye perceives differences in brightness a lot better than it does differences in color. This is an important fact behind how we've elected to store and transmit video. There have been numerous ways to hook up video output to a television over the years. What signals do they provide? This video focuses on luma, the brightness or black and white component of video that is transported in several of the cables seen here. But what is luma? How does brightness relate to color? How is luma created from some amount of red, green, and blue? Why did it stick around after the move to color television in the mid-20th century? In order to understand what luma is, I believe it is a good idea to understand the journey of our understanding of light. In order to do that, we need to go back in time. 1672, Isaac Newton proves that light is responsible for color. Using a prism, Newton split clear white light into 7 visible colors, the same colors we see in a rainbow, and then recombined them into white light. Essentially, he scientifically established our visible spectrum. Color exists only in the eye and the brain. It is our reaction to detecting different wavelengths of light. Our journey isn't only about understanding and measuring light, but also how we perceive it. 19th century, discoveries are made that prove the existence of light that we cannot see, including gamma rays and X-rays. Our visible spectrum occupies a very small portion of the light that is out there. The value of the wavelengths we see between ultraviolet and infrared is about 400 to 700 nanometers. We also discover that the human eye has 3 kinds of cone cells that sense light, and they have peaks of their spectral sensitivity in short, middle, and long wavelengths. This knowledge gives us a useful advantage when it comes to intentionally tricking our eyes into seeing the image we want to reproduce. 1913, the International Commission on Illumination is established. They help develop basic standards and procedures of metrology in the fields of light and lighting, among many other things. You have a difficult question about light? They have an answer. 1924, the CIE publishes the luminous efficiency function. This function is subjective by nature as it considers human perception of light. Observe 2 lights, one blue and one green. If the lights have equal radiance, how bright would they appear to you? Would they appear the same? In reality, the green light is brighter than the blue light because we are more sensitive to green. If we are to recreate a scene using light on television, this is an important aspect to an accurate recreation. Late 1920s, William David Wright and John Guild independently conduct color matching experiments using human sight. Test subjects have a screen placed in front of them that has been split in half. A color is projected on one side. The subject would make adjustments to the intensity of 3 light sources, red, green, and blue, that are projected to the other side of the screen and attempt to match the target color. These experiments showed us that we can break down white light into many colors, generate those colors using 3 primary wavelengths, and also manage to mathematically put